Hey, how's it going? Finished editing my second pass of my book, so I'm happy about that. Leetcode 2685. Count the number of complete components. You're given an integer n. There is an undirected graph with n vertices numbered from 0 to n minus 1. You're given a 2D integer array edges where edges of I equals a of I, b of I. Denotes that there exists an undirected edge connecting vertices a1 and b1. Return the number of complete connected components of the graph. A connected component is a subgraph of a graph in which there exists a path between any two vertices and no vertex of the subgraph shares an edge with a vertex outside of the subgraph. A connected component is said to be complete if there exists an edge between every pair of its vertices. So, and yeah. All right then. Okay, from the picture above, you can see that all the components of this graph are complete. Hell yeah, you can. 50? Is this the first of two? What? What? How can it be 50? Well, this should be an easy problem then, right? Should just brute force this shit. All right. Okay, A does not equal B. There are no repeated edges. It's dumb as shit. I think we still probably want a union find. Why? What? There's no reason. We just sit there and go through every single one of these. All right. Union find, whatever. Okay. Is there a way to do it with sets? Just like combine sets repeatedly? These are so small, I could probably do it that way. Here, let's see. Okay. All, I don't know, all sets or something. This is dumb. This is dumb. Stop being stupid. Groups equals I for I in range n, right? And then union A comma B is seek A if groups of A equals A, then return A, else assert groups of A is lesser than A and return seek of groups of A, right? Standard union find. So if seek of A equals seek of B, then return, I guess. I don't know. Otherwise, minimum equals min seek A, seek B, and then, yeah. Then we have to join the higher of the lower, right? So min and max. And then we are going to say, what? We're going to say groups of max equals min. And then assert seek A equals seek B equals min, like that. I can probably remove this. Okay, so let's go through and let's make our groups here. So we're gonna say for A comma B in edges. Pretty friggin' simple. Assert seek A does not equal, that is not true. That is not true. Union A comma B. And then we need to include some counts here. Well, we can't do it yet. Okay. So counts equals 0 for I in range n, right? And how many things are in each of the groups? Number in group, right? We'll go like this, for I in range n, and then number in group of seek of I plus equals 1, and then number of connections. Let's not have it be counts because that's confusing. Number of connections like this. Seek of I plus equals 1, and then I. What the hell is I? A comma B is what I meant. And then I think in here, let's say return value equals seek of groups of A, and then groups of A equals R, and then return R like that. All right, cool. And we want to know how many root groups there are. And I think what we will do is we will say number in group. Well, no, we can just do it like that, so that's fine. For number in group, comma, connections in zip. Number in. I feel like I'm making this more complicated than it needs to be. Yeah, maybe it is supposed to be a medium after all. Okay, so CNT equals 0. And then how many connections are there going to be in a complete group? So if there's 3, there's going to be 1, 2, 3, right? If there's 2, then it's invalid. If there's 4, be like 1 here, and that adds 3. Boom, 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 right? What is that? N minus 2 times n minus 1 divided by 2? Is that right? Or is that... Let's see. If c minus 2 times c minus 1 divided by 2 equals... Yep, that's not what I meant to do. Equals c, then c and 2 plus equals 1. Is that correct? If there's 0, it shouldn't be negative 1. Well, no, it would never be 0. That doesn't make any sense. It would be 1, and that should be 0 connections, right? And if there's 2, then it should be 1. Yeah, well, that ain't gonna work. from this one you would have 2, and from this one you would have also 2. Oh. Would it be the same, right? No, that includes the duplication. That's why you don't subtract to output null. Now that's interesting. Return CNT. So sad when that happens. Okay. So let's see here. So if n, then print n comma c so 1, 2, 3, right? 1, 0 connections. Good. 2, 2 connections. Life is pain. Yes. Well, no, that is incorrect. That should count, that should count, that should count. Output is 6, and we expected 3. Why the hell is output 6? That's why output is 6. All right. Submit. Okay. Yeah, that should have been a medium.